So in this video, we're going to discuss the second derivative and what that particularly tells us about a function. So we're going to first start with the notation, which this isn't going to be overly surprising, but let's say we're going to call something f of x or y is how we're naming this function. Well, the first notation, the notation that we're familiar with, the prime notation, the second derivative would be f double prime of x, or y double prime. If we were going to use the Leibniz notation, then all we're going to do is call this d squared f over dx squared. Or if it was y, d squared y over dx squared. So that's our notation per second derivative. And so if the first derivative tells us the rate of change of the original function, then the second derivative tells us about the first derivative. That is, if the rate of change of the first derivative is increasing, the second derivative is positive. If the rate of change of the first derivative is decreasing, the second derivative is negative. So let's consider what that tells us graphically. Let's say we had some function and it took on the following shape, a very familiar shape. Let's say here's f of x. And if we consider the first derivative and we look at these points, and so we know the first derivative tells us whether the function is increasing or decreasing. And so on this side, I would note f prime is less than 0. In other words, the first derivative is negative. And on this side, f prime would be positive. Well, what I would also notice is that here the derivative goes from very negative and swings around to less negative, and then here it turns to positive. So here I would say the first derivative is actually increasing, and so f double prime is positive over this entire function. What that shows and what that's proving us is that if the second derivative is positive, the graph is actually concave up. So if a graph is concave up, the second derivative is positive. Let's look at a different function. And let's say now this function takes on a shape more in this manner, like some parabola facing down. Well, if we consider the first derivative, right, the slope of these tangent lines, then what I would note is that on the left side of this parabola, f prime is positive because the function is increasing. And on the right side, f prime is negative because the function is decreasing. So what's happening here is that the first derivative is actually decreasing. It's going from negative to positive. So if the first derivative is decreasing, the second derivative must be negative. And essentially what this shows is that if f double prime is less than 0, we will get a graph that is concave down. So if we want to consider some stuff graphically, f of x tells us the function value. F prime of x tells us increasing or decreasing. And the second derivative, f double prime of x, tells us concavity. Alright, so let's consider each of these following things, and we're going to determine if it's positive or negative. So f of negative 2. At the point when x is negative 2, is the function itself a positive or negative value? Well, since the actual function is above 0, f of negative 2 is positive. What about f of 2? When x is 2, the function is less than 0. It's down in the negative, so f of 2 is negative. So that's what we mean by the function value. Is the graph above or below the value of 0? The first derivative at these points we're considering is the function increasing or decreasing. So let's consider f prime of 1. At this point here, is the function increasing or decreasing? Well, the function's obviously decreasing, and we know that when the function is decreasing, the first derivative is negative. So let's consider f prime of negative 1. At this point here, is the function increasing or decreasing? Since the function is obviously increasing, f prime of negative 1 would be positive. Lastly, we know the second derivative tells us about concavity. So at f double prime of negative 2, so at this point here, we want to think about the concavity. Since the graph is clearly concave up, bent upwards, the second derivative at negative 2 is positive. F double prime of 0, at this point, we want to consider, is the graph bent upwards or downwards? I would say that graph is bent downward, so f double prime of 0 would be negative. So we've considered graphically what's happening. Let's think about what's happening from a table. So again, the first derivative tells us if the function value is increasing or decreasing. The second derivative tells you if it's positive or negative. So the table below gives the number of cars in millions, C, as a function of the year t. So if I consider this table as time goes on, as time is increasing, what's happening to the number of my cars? It's increasing also. So I would say the first derivative is positive. And the reason that's positive is the number of cars is increasing. Okay, so I'm going to pause this for a second just to take this line away. Alright, and now we're going to discuss the second derivative. So the second derivative, we want to consider the rate of change. Now typically we want that down to an individual unit, but here what do you notice? These are all increasing by the same amount. They're all increasing by 5. If those intervals are different, then we would want to go through and check each individual rate of change. In other words, what I'm saying is we want to consider, as time goes on, does the increasing actually happen at an increasing rate? So if we look, to go from 106.7 to 108.4, we would add 1.7. And here we would add 4.3. To go from this point to this point, we would add 8.1. Here we would add 9.7. And here we would add 14.1. So what you notice is the speed at which this function is increasing itself. And so therefore we would say f double prime of t is positive because the rate of change is increasing. Let's consider one more example. The table below gives the production of soda bottles, B, by an employee as a function of the number of hours worked, T. So considering this table, is B prime of T positive or negative? So what do we notice? As the function goes on, over time, what happens to the function? The function is increasing. So since the function is increasing, B prime of T is positive. So that one seems pretty obvious, but what's going to be less obvious in this case is actually what the second derivative is going to be. Is it going to be positive or negative? So again, what I would notice, the inputs are changing by the same amount every time. We're adding 2 to get from one point to the next. But let's look at what's happening to the actual output values. During those 2 hours, the person made 140 bottles. During this 2 hours, though, they only made 120. The next 2, they made 100. Then only 40. And then 15. So it appears that over time, the employee is getting tired and the rate of production is actually slowing down. Since the rate is slowing down, we would actually say that B double prime of T is negative, because the rate that the function is increasing is actually decreasing.